make a tutorial for Codeforces Round 932 div 2 divisor 2, and we will start with the first problem, problem A, entertainment in Mac. Okay, with this problem they will give us a string, let me example, like CPM, and they want us to do these two. We can apply these two types of operations into the string. The first type is we add the reverse of the string to at the end of the string, like we have CPM, and the reverse of the string is MPC. So combine together and we got CPM MPC, and this is our final string. The second operation is we reverse the entire string, like we have CPM and the reverse is MPC. So we just reverse it and we got MPC. Okay, no combined. And they provide us an even integer n, and we need to apply exactly n operations to this string to make it lexicographically smallest. Okay, for example, with the string CPM, the first operation we can do is reverses, and we will become MPC, and we start reverse it and we become CPM, we become MPC, become CPM, and become MPC, and again CPM. Okay, another example, the word grip, GRIB. The smallest string that we can have from this string is BIRGGRIB. Okay, and the following operation is we make it to the reverse of it, and we become BIRG, and we use the first operations, and it will become BIRGGRIB, and this is the smallest string that we can have. If we just reverse it, it will let me see, if we just reverse it, it will become BIRG, and eventually it will become GRIB, and this is bigger than the string because G is larger than B. Okay, so in this problem we can see that the key point to solve this problem is integer n is even. So with the even integer n, what can we do? We have now we have a comments that with the string a, like ABC, and we need to apply two operations. Because this string is smaller than the reverse of it, like CBA, so we just and the number of operation we need to apply is even, so we just need to reverse it, and it become ABC and ABC, and this is the smallest. But for the string which CBA, the reverse of this string is smaller than this string, is ABC. So for this string, we will have the strategy that we need to reverse it for reverse, and it will become ABC. But in the second operations, we need to apply the first type of operations, and it will eventually become ABCCBA. For next operations, we just need to reverse it and reverse it over and over again. And with this strategy, we will have the smallest lexicographically string in the final after apply exactly n integers. Okay, so this is my code. I check if the reverse is smaller than this string, so I can make it the reverse, and I add the reverse of the reverse is the string that we are given. So, and for next operation, we just need to reverse it over and over again, so I will return it in the final. And if the reverse is larger than s, larger or equal to s, we just output that string, because we just need to reverse it over and over again. We don't need to apply the first operations. Okay, so it's the end of the first problem. The second problem, informatics in Mac, and in this problem we are provided an array with length n, and they want us to divide it into k subsegments with k is bigger than 1. In the way that max of each subsegment is equal to the same integer, like max of the subsegments 1 is equal to the max of the subsegments 2. And what is max? Max of an array is the smallest non-negative integers that does not belong to the array. For example, max of the array 2, 1 is 0, because 0 does not belong to the array. Max of the array 3, 1, 0, 1 is 2, because 1, 0 and 1 belong to the array, but 2 does not. Max of the array 0, 3, 1, 2 is 4, because 0, 1, 2, 3 belong to the array, but 4 doesn't. So for this problem, like well, we have an example, 0 and 0. We can clearly see that we just need to divide the array into 2 subsegments, because if we divide into 3 subsegments, I will say that n and we have the max like n those 3 subsegments is equal to n. We can combine these 2 subsegments into 1, and we will get n and n. Why can I say that? Because, for example, 0, 1, 0, 1, this of max is 2, this of max is 2, and those 2 combined is just the max of 2. yeah, and this is right. So like we have three subsegments that have the same integer. We can combine these two subsegments into one, and we have two, and four, so on for 4, 5 to infinity. Okay, and with these comments we can solve this problem by use the prefix and the suffix max. Okay, what's it, the prefix max? The prefix max is the max of the array that counts from the beginning of the array. Like I have this 0, 1, 7, 1, 0, 1, 0, 3. So the prefix is the max from this to this to this to this to this, and it starts from the beginning of the array. So I will write the max the prefix max of this array. It will be 1, 2, 2. This is 2, 2, 2, 2, and 2. Okay, and we will have the suffix max of the array, and the suffix is the max of the array that start from the end of the array. Like the suffix is 1. It's 2 here, here, from here to here, from here to here, from here to here. Yeah. So I will write it 0, 1, 2, 2, 2, 2, 2, 2, and we will check if one of those max is if this max is equal to the next max, if this prefix max is equal to the next suffix max, like this. So it means that the max of this array is equal to the max of this array, and we can get the answer easily. So this is my code. Okay, I input the array. I get the max of the prefix, the max of the suffix, and I check if they have the max with similar. If we have similar max, and if they don't have any similar max, I just output they have no solution. Otherwise, I will output the solution, and it's the end of the problem 2. 3C. In this problem, we will have an array that contains A and B, and we need to choose P numbers that for each P is smaller and or equal to n, and all P is distinct. So we will have this formula to calculate the time to read the message, and we'll have the maximum time that they will use to read the message. Okay, so they ask us if we can maximize the number of message that can be added into one message that contain many small messages. Okay, what is the maximum possible size of a set of message? And for example, with this test case, I will write this test case. Free okay 2 4 free 4 free and 2 free. So with the smartest way to do it, the maximum possible size that we can do is we choose those free message is this one, this one, and this one, because they will give us totally 8 times. You can see it. You can see it here. Okay, with the formula K A P I is equal to 1 from 1 to K, and plus with K minus 1 to from 1 is the absolute of BPI. BPI plus 1. Okay, we have this formula, and we also have non-equation that this formula is smaller than L. L is a number that we have been given. L. Okay, so we will do something more special. Without losing the we can add something like BPI is smaller than BPI plus 1. It don't lose the general. Okay, and we will make this non-equation into K I A P I plus B. Let's see if we have KBP. Okay, K minus 2 KB K plus minus 1 plus BPK minus 1 plus BPK minus 2, and so on until BP2 minus BP1 smaller than L. And we can do this. We not this, and this. So the final non-equation is K I A P I plus BPK minus BP1 is smaller than L. So we can sort the array with increasing BI. And for greedy, we will need this one to be smallest. We will check the range from L to R of one array. We need this one to be smallest, so we will use set multiset to do it. Okay, and 2 pointer plus with 2 pointer. Okay, and this is easy to be done with multiset and 2 pointer, and this is my code. Okay, I short with increasing bi, and I give the current. I use 2 pointer. The current API that in use multiset, and I make another unused multiset, and in unused multiset I will add all AI. So like right now it's BPI. Is this one is BBK minus BP1, and while we can add, we erase the number is smallest from unused multiset, and we add number that to the used multiset. We do it for this is for the first from 1. This is for case from 1 to I, and this is case from J to I, and we can see that this is this one, and we will find if the unused the new number that we need to erase is from the unused multiset. We just erase it, no problem. But if the number that we erase is in the used multiset, it means that we need to erase one element from this. Okay, and after that we need to check if the unused size, and this one is, we need to do a while. So if current ans plus with the smallest number in the unused multiset is smaller than L, we can add it to the used multiset, and just take it from the unused, and the answer is the maximum possible size of the used multiset. Okay, it's done with problem 3. To write the complexity of this, this complexity of this code is around n square multiplied by log 2 of n, with log 2 is for the set, and n square is for two pointer. Yeah, okay, so it's the end of problem 3. Of 4th problem and the final problem that I can solve in the contest is problem 4. In this problem, they need us to calculate the number of pairs such that x is smaller or equal to y, and y is smaller to or equal to c. C is a given number, and x plus y is not contained in the set S is the given set, and also y minus x is not contained in the set s. Okay, I can see it input here. Okay, to do it, we need to know about the exclusion theory. We have two problems to do. Is the first problem is like we have two integer. We say I have a pair is xi. Okay, so if xi, we have two things to do. Check. Okay, we need to check if x plus y is equal to ai, or x plus no, y minus x is equal to aj, with aj is okay, we need to check if xi is one of these two cases. And for this problem, we need to use math. So in the first case, y is equal to ai minus x, and we need to know non-equation that x is smaller than I and I smaller than c. So write this first and this second. So x is smaller than, just place this. Okay, so x is smaller than ai divided by 2, and the second is ai minus x is smaller than c. Ai is smaller than c, and x is non-negative, so this non-equation is always true, so we don't need to count it. And the second is I minus x is equal to aj. When we combine these two, so like the first, so we know non-equation. Okay, x is equal smaller than, so we can summarize that y is aj plus x. So that is here aj plus x minus x. Only aj is always right, so we don't need to care about it. We only have one thing more, is aj plus x is smaller than c. And so we have cx is smaller than c minus aj. Okay, so for each elements of the array, we will have the number of x that satisfy the first condition, and the number of x that satisfy the second condition. Okay, so let me say that w1 is the number of satisfy first condition, and w2 is the number that satisfy the second condition. So the number that satisfy one or two condition is, I will say that w1 2 is the number that 1 or 2, and is equal to 1 w1 plus with w2 minus by w that satisfy both 1 and 2 conditions. This is inclusion theory. Okay, so how can we calculate it? To calculate the number that satisfy both conditions, we need to use binary search. Okay, so let us say that again. So we can say that y minus x is smaller than y, x plus y, right? Is always right, because yeah. But in this, so the first one is equal to ai, and the second one is equal to aj, but this one is smaller than this one, so aj is definitely smaller than ai. Okay, and x plus y is equal to ai, so y is equal to ai minus x, and y minus x is equal to aj, so y is equal to aj plus x, and these two things is equal because y is equal to y, so ai minus x is equal to aj plus x, and just need to solve this one, and ai minus aj is equal to 2x. Put it here, and we got ai minus aj divided by 2 is equal to x. Oh, it's beautiful. Okay, so we just need to count the number x that satisfy these two, and we use binary search. Okay, so for an modulo theory, and we can see that if they need to divide by 2, and x is an integer, so ai minus aj must divide it by 2, right? So ai minus 2 is equal to aj minus 2. We will check if ai is even, so aj need to be even, or if ai is odd, so and so on, aj need to be odd. Okay, but we forgot one thing, that y is smaller than c. So what does it mean? We can say that y is equal to ai minus x. It needs to be smaller than c, and ai minus x is ai minus aj divided by 2 is smaller than c. Okay, so 2ai minus ai plus aj divided by 2 right, ai minus x. Okay, in my solution I use the another non-equation. Is aj plus x naught ai minus y x plus x is smaller than C, and aj plus x, which is x is equal to ai minus aj divided by 2. Okay. It's 2 plus 2 divided by 3 is smaller than C, right? And aj plus ai plus by 2 is equal to C. Okay, okay. I'm wrong here. I used the first, not the second. Okay, so ai minus x is right. I'm wrong at first. Okay, ai minus x is smaller than C, and ai minus x is equal to ai with x is equal to this one. Yeah, what's the point? ai minus x, y is equal ai minus x. Okay. ai minus aj divided by 2 is smaller than C, right? And ai minus aj ai plus aj divided by 2 is smaller than C, and ai plus aj divided by 2 is smaller than C, and we can clearly see that this equation is always right because ai is smaller than C, so ai plus aj is smaller than 2C. Is totally correct. Yeah. I don't know what I done here, but yeah, maybe my wrong. Yeah, my wrong. Yeah, we don't need the binary search here. We just need to care about if it's odd, if ai is odd, so aj is odd, and ai is even, so aj is even. We just need to care about it. Am I wrong here? But fortunately it's got accepted. Oh, I can see this number is always ai is always smaller than this one. Okay, so I will check for each condition. So for the first condition, I can see that the number of numbers that satisfy the first condition is ai divided by 2 and plus 1, and the number that satisfy the second condition is C minus ai plus 1. With these, yeah, with these two. Okay, and check for the third condition, and I got Chan is even in Vietnamese, and I check if aj is even, so I check only ask for the even number before a for j, and if aj is odd, so I just ask for the odd. Okay, and the total, our total number is C plus 1 plus with C plus 2 and divide by 2 is the number of pairs possible minus by W1 plus W2 and minus by W both. Okay, and I got the answer here. Okay, so it's the end of problem 4. Thank you for watching. See you again.